Good morning. I'm sorry that this video is going to be coming to you a little later. This is the second time I've had to record it now because the first recording somehow stopped in the middle. So without me knowing, so I kept on teaching until I realized that it stopped. So I'm going to have to go back over what I was doing. I want to really quickly go over your homework. Please make sure that the following little squares are in the correct pockets because this makes all the difference. You can make the little cute pockets, but you learn nothing unless you know for sure what you put in each pocket was correct. So you were having to categorize each of those little descriptions into either mutualism, commensalism, or parasitism. There are 4 parasitism paper pieces, and I will read them to you. It's the one that has the wasp and lily, the one with heartworms, the one with the cuckoo, and the one with a spruce tree. Those are the 4 parasitism. Maybe at the top corner you can write a P to indicate that those are parasitism pieces in case they get mixed up. Your next one is commensalism. There are 5 of them. The cattle egret, okay, is one. The whales is one. The orchid is one. The remora is one. And the hermit crab. And then all the others, there's 7 more. They are all mutualism. So make sure my computer doesn't go to sleep. The Egyptian plover, the honey guide bird, the barnacle, and whatever else. I'm just having to look really quickly. I'm sorry, not barnacle, the barracuda. Barracuda, the tree sloth, the acacia tree, the honey guide bird, the oxpecker, the golden jackal, the Egyptian plover. Those are all mutualism. Okay, so make sure you check those, make sure they're in the right places. Put a little letter up at the top corner to tell yourself which is which. Those of you who are turning in your assignments late, I will give you credit, but they will be late grades. You need to have them in on time because I'm going to try in these recordings to go over the answers so that you get immediate feedback as we move forward, because you're going to be getting quizzed. For instance, there's a quiz today over section 3 and 4 notes. It's up on Google Classroom. Please, when you take it, academic integrity is really important at this point. Please don't use your notes or the book or any other person or the internet or any of that. Please make sure that you are using only what your brain knows to answer the quiz. You have time to study before the quiz because you don't have a time limit in terms of what time you have to take it, but just know that the quiz will shut down today. You won't be able to take it tomorrow for full credit. Okay, so make sure that you're getting your work done. If you have an extenuating circumstance, please email me and let me know. I have office hours today from 2:30 to 4 like I did on Monday. Feel free to drop in, ask me any questions you may have. It's a drop-in office hour, so you don't have to be there the whole time. And you just come in, ask me a quick question or a few questions or ask me for help, and then you can leave. So 2:30 to 4, the link for that will be up on Google Classroom later today. Okay, now we're going to get to section 5 notes. Section 5 is ecological succession. So on your interactive notebook, you're going to want to write today's date and then ecological succession flip book. Let's see, there we go. And then the page number. I can't remember what page number we finished on Monday, but it's the very next one. So if it was 102, or if it was 101, then put 102. If it was 103, put 104. Okay, I just can't remember, and Lily's not here for me to ask at the moment. Okay, so section 5, notes, ecological succession. And same thing, next number. Okay? All right. I'm doing it this way because my first video was on the whiteboard and I'm just, yep, we're moving on. I can't do that again. Okay, so we are going to be talking about ecological succession. Ecological succession is something that you see and you just didn't realize that you were seeing it. We're going to put some science words to it. So our question for this set of notes is food availability and temperature can be a what for a particular organism? Now, that doesn't make sense right now because you haven't learned the terminology, but once you do, then you're going to be filling in this blank, a blank for a particular organism. So food availability and temperature can be what for a particular organism? Okay. Ecological succession is our heading. All right, the first thing we're going to define is something called community. We know what community is in our natural world. And let me go back. Community is something that, a term that we use often in reference to people being in community. But today we're going to talk the science version of that. Community is looking at the, made up of the populations of organisms that live in a common area. Now, let's remind ourselves. So we have species. Let's say we have the species squirrel. Okay, so you have a squirrel. When there's a bunch of squirrels in a specific area, let's say your backyard, the squirrels make up a population. So there's a population of squirrels. But in that same area, squirrels aren't the only thing that exists. You have trees, you have grasses, you have insects, you have people, whatever is in that same area. There are different populations. So a community is all of those populations that you're looking at or in a specific area. So if the area is your backyard, you're looking at that area. The community is all the living organisms in that area. Okay? Next, limiting factor. So when you're talking about organisms living in an area, there are things that are going to limit its ability to be in that area. So this is anything that limits an organism's ability to live in a particular environment. Examples of this would be lack of water causes grass to die, which causes certain herd populations to decrease. Right? So if you're talking about deer or sheep or goats or cows that are grazing on the grass, but the grass dies off because there's a lack of water, then those animals, whichever population you're talking about, will either have to leave to find that grass somewhere else, or they will die possibly if there's just not enough food. That's a limiting factor. It limits the ability for organisms to live in an area. Okay, the next term we're going to talk about is tolerance. We hear this a lot in just regular talk, but in this case, in science, tolerance is the ability of living things to survive changes in their environment. Okay? So those are some terms we're going to need moving forward with ecology. Let's do our next topic here, which is succession. So let's define succession first, and then we'll talk about some examples of what this means. So this is the process of gradual, natural change. I'm going to move this a little bit so we get more of that. Okay. And species replacement that takes place in the communities of an ecosystem over time. Okay, so we're going to see changes. Let's say we're driving down the road and we look over and we see a big area that has been cleared out completely of trees. What would happen if instead of somebody building on that area, they just kind of left it and it just was doing what it was doing? What would happen? Well, this actually happened near us. They cleared out this area off the road, and they built something that looked like it was going to be a doctor's office near my house. And then for whatever reason, I think it was during the original recession back in 2008 or so, nothing ended up moving into it. Nobody ended up caring for the land it was on. And over the next 12 years now, it has gone from being cleared out with a building to the building was totally overtaken by trees and grasses and bushes, and you couldn't even see the building from the road after a while. There was so much growth there. So that process of gradual natural change is succession. Now we're going to talk about two types of succession. So you're going to draw a chart. My chart's going to end up taking up the rest of my page here, but I'm going to leave we'll to the side write a definition in a minute. Okay? So my box is going to be divided in half, and I'm going to have a header. So this is going to say primary succession, and this is going to be secondary succession. Okay? So primary succession, this takes place on land where there are no living organisms So you think, where is that? Okay, so an example of this would be after a volcano erupts. That would be an example of when this would happen. Okay, it's so hot and so destructive that nothing living would exist afterwards. The ground would be charred. There wouldn't be bacteria. There wouldn't be fungus. There wouldn't be plants or animals. It would just be barren. And there really wouldn't even be soil. The soil would be burnt up and hardened and charred. So then what happens? So we have something called a pioneer species. So the first species to populate the area is called pioneer species. So what happens with this? Eventually, the pioneer species die, which adds, so adding organic material to help form soil for plants. Okay, I'll move this up so you can see. Okay, so this pioneer species would be like a moss or something. So you have a big volcanic eruption. Nothing exists. There's not even soil. Some mosses might start to grow. Some of these pioneer species might start to grow, and then they actually die off. And as they're dying off, they put organic material, essentially creating the soil that then plants will grow from. So that is what primary succession is. Secondary succession is what we were talking about a second ago when I was talking about the business that was built and trees were built that grew up around it. So this is the pattern of changes that take place after an existing community is destroyed. So when does this happen? Okay, so examples of this would be fires, flooding, farming, logging. These are good examples of when you would have an existing area destroyed. Okay. All right. So this process may take a shorter amount of time. I mean, think for me, I was saying it was like 12 years worth of time where I saw an area go from being completely cleared out with a building built on it to growing back to almost kind of what it looked like before with like almost wooded areas. So 12 years so it may take a short amount of time to reach what's called the climax community. We're going to define that in just a second, since soil already exists. So the reason it's shorter time is because over here soil is having to be created, and over here soil already exists. So let me fix this for a second. Since soil already exists. All right, the last thing we're going to write is defining climax community. And since I have run out of most of my room on my page, I'm going to write it over here in this section. I'm just going to draw an arrow and define climax community. So, and I'm going to turn it so that you guys don't have to look sideways. Climax community. A stable community formed after primary or secondary succession and basically after this point there's going to be little or no change occurring. Okay, remember I said after a while it just kind of looked like what it used to look like, and you're not going to see change. The same way you'd be driving down a road and you would see the woods on either side of your car, and they don't look like they change year to year. They stay pretty stable. That's considered climax community. But if we chopped it all down, it wouldn't stay that way for very long. It would grow some grasses, some bushes, then it would grow into some bigger bushes, some small trees, some pine trees, and then over time you would get hardwoods. So that is secondary succession, and that is the climax community, is when that process of change kind of lulls out. Obviously, primary succession would take a lot longer to get there. Okay, these are your notes for today, and I will see you guys later.